Well, now we go on to the second workshop or second presentation of today, which is from Tellor, the Oracle platform. Now, is JG here somewhere? I see JG. Where are you, sir? There you are. Let me pin you in the nicest possible way. JG actually, as those of you know, when we did our kind of welcome events, JG was in the hackathon, the last hackathon, so he knows exactly what this experience is like. So yeah, JG is one of the developers at Tellor, which are a fantastic DeFi-focused Oracle. He's going to talk you through everything about Tellor, how to get started, answer your questions, and again, all this content will go onto the Medium, into the Hackathon, on the README, on the YouTube. So if you miss anything, you can digest it later. Welcome, JG, and tell us more about Tellor.
Oh, hello. I'll just share.
You're quite quiet, but maybe that's a temporary thing.
Sorry. Just share my screen.
Okay, that's good.
So everyone can see it. So I go very briefly what Tellor is, what we do, and then I'll just start coding a simple project that I thought of for us in this hackathon, and we'll build it together and see how things work. So basically, in short words, like Tellor is a decentralized Oracle network. So we use a lot of incentives to provide trustless data on chain. So you have a mix. We have a mix of like staked miners and proof of work miners that all work together to submit this data on chain. And I won't go too much into these sort of details. I kind of rather focus on what we are building like for this hackathon stuff. And we recently launched a very interesting product called like Tellor Playground, which is supposed to help people get started with building projects using Tellor data without any hurdle. And for this hackathon, we thought about like two major challenges. The first one is it's a simple like DeFi product that uses Tellor as a price oracle. So you can think of like stable coins, derivatives, and any other sort of like DeFi-ish thing that uses Tellor data, which right now we have over 50 price points that we can put it on chain. So you can choose a lot of token prices, a lot of coins, BTC, and everything such. So it's a good tool, like to use Tellor as an oracle. And the second challenge, which I think it's a little more creative one, it's to actually expand a little bit beyond the only price feeds and DeFi stuff, and think about how can you use an oracle for different kinds of applications. So for now, we should like the second challenge. We want you guys to think of other ways to use Tellor Playground and other kinds of data. And I'll be doing exactly one of these stuff right now. And it's a small project that I've been calling Space Lottery. Basically, it's just like a space lottery, and I'll go through them. So, for example, you can find the documentation of Tellor Playground and a lot of other documentation in our website. I'll link everything after this, but what's the idea? So I'm gonna take an API of the International Space Station, which is orbiting around the Earth very fast. And they have a very nice open API that you just call it, and you get back the current latitude and longitude of the International Space Station. So the idea that we want to build here is just a betting contract that you can bet at the position the International Space Station will be at a given time. So if you want to see like an example how these data look like, it's very simple. It's kind of small here. Sorry. It just returns a timestamp, a latitude, and a longitude. And that's it. That's our main contract. People can bet on the time, the position, and then you can win a prize. So I'll start with, I already have set up a hard hat environment, but this could also be used in a truffle environment. It doesn't make much difference. And I think the first step would be to install a small package we call using Tellor, which basically just installed through NPN. And this provides a helpful functionality for you to be able to interact with Tellor oracles easier. So basically you have to just install, but I already have it installed. And so I just import here the using Tellor contract. And we start building our space lottery. If you have any questions, you can like ask in the chat, or I can keep answering while I type. So to be able to access the using Tellor functions, you just have to inherit it from your contract. So by now you already are able to start using the using Tellor functionality. The only thing left to do, you have to pass a constructor, the Tellor address, which will be using data from. So in the documentation, there's the address for all testnets. We have the Tellor playground, all of these. I'll be using WinTV for this one. And that's just how you pass the constructor to the. Yes, that's basically the idea of the constructor. And now I'll kind of walk through how I've actually built this before, but I'll think about my reasoning, and also we go through some of the more like Tellor-like concepts you have to think about when you're interacting with oracles. So for this contract, it will be very simple. We have basically three main functions. One function is for betting. One function is for claiming your prize if you, for any chance, you want it. So you're not sure what kind of parameters we need here. And the last function we'll probably need is draw result. So we need a way to read the data from Tellor into our lottery contract. So these are all stereo functions. I intend for it to be very trustless, so no owner functions, no kind of anything like that. And that's for also, like, if you think about a betting contract, the first data structure you have to do is a mapping of an address to another mapping. Since you're betting like on timestamps, you need a y-int, which will be our timestamp, to another y-int, which will be the position we are betting for. Actually, let's just do a position here and put bets. And so one thing we kind of have to understand, anyone who's like trying to build with Tellor, is that right now our system only supports y-int values as a value. So because we were thinking about prices, in our case, we kind of have to do a sort of like workaround, because we want to add three values inside a one Tellor value, which will be the latitude, the longitude, and the timestamp. So for it, I'll be using like smaller y-ints, which is helpful because we can fit all those three values inside a single y-int, and therefore the Tellor system won't have any kind of problem with it. And that's the basic idea. So let's just go implementing the first like functions. Another thing I'll kind of want, it's needed, it's for Tellor Playground. Basically, it's an open system where you can just fit the values yourself. So, for example, if I want to have an updated value of these lottery results every 5 minutes there, so I'll just define an ID, which is like any number you wish. Just make sure, like, if you're not using some other ID that other people is using, I'm going to use 75 just because. And the other thing I kind of want is a ticket price, because I don't want it to be free to play. Otherwise, there will be no jackpot. In this time, I'll be just, I don't know, maybe this amount of way is fine for our project. One thing you're probably wondering, like, is since the space station it's orbiting around the Earth, and you kind of know its velocity, you kind of know its current position, so it's reasonably fair to assume that people will be able to give educated guess on its positions, right? It's not completely random event. You kind of know where it is. But in our case, it's a bit more specific. So one thing that I'd like to mention is that the actual value that comes from Tellor, the official value, is just the median value of 5 or minor submissions. So we have minors, and they all each try to solve a proof of work challenge, and then the first 5 that solve, they are able to provide this value, and the median one is selected to be the official value. So therefore, since the position changes every second, it's very hard to be sure of which position was the space station when this minor, which is the third one minor, called the API. So that won't be much of a problem. So I'll just do a require here that the message.value is equal to the ticket. Otherwise, people won't be paying to play. And I also kind of want to think about times, because especially with oracles, it's kind of a sensible information. If you're thinking about getting information that is too soon or too fresh, it's not, you might get into situations where you don't have any time for a dispute. So for example, maker oracles have it. A value is only official after a certain period of time has passed and no one has contested it. And the same thing happens with Tellor. So we kind of need to make sure that every time we read the value from the oracle, it's at least, I don't know, 10 minutes old or something like that. But in essence, what we're thinking about here is dividing the overall like time in the different slots. So it's the slots you can bet on. I'll be thinking about like slots of 10 minutes. I think it's enough, because it's enough slots per day, so we can have a lot of betting, but it's not too soon. So we can, like, the shorter the time span, the less unique bets you can put in, because the timestamps will be repeated, and then it will be easier to get a result. So that would be a timestamp, and also a latitude and a longitude. And basically that's what we're gonna create a position. And that's our like very basic betting. Of course, we need to do some kind of filtering, because I'm just doing like an experiment here with a hackathon project, but you might need to put other types of requirement. For example, you probably want people to bet only on future timestamps. Otherwise, you would be very easy to predict a position it was of a value you already know. So I'll do that a little bit later. And I go, another issue kind of, as I was designing this system, and I kind of thought, is that since I want it to be very cheap and very easy to use, the price, I don't want to have to iterate through all the bets to find a solution or to find a winner. Ideally, if you are a winner, you can claim the prize yourselves, and this contract doesn't need to do any kind of expensive operation iterating through all the placed bets and to find the winner and then like transfer him his prize. So I'll be using like a sort of a pool approach where basically the winner can request its prize. But for that, we kind of are in trouble, because if you think about, there's a jackpot, and if two people made the exact same bet, and the prize will only go to the first one who actually called this function. So we kind of need to make bets unique. And I think the best way to do that is like we hash the results of the structure of timestamp, longitude, and latitude, and that will give a unique value. So two people cannot bet on the same exact sort of like values. So that will just be a mapping that I call unique bets. And when people are betting, we will actually have to do this like which is just a timestamp, latitude, and longitude. This way, like there's no way for two people bet on the same result, because here we'll put a requirement that unique bets for this exact same hash is false. So it's always a good practice to put error messages must page play. Yes, so that's at least like I think I got the name wrong here. That's our basic structure on the betting side. Now for like the claiming step, we kind of need to provide the same kind of arguments, which is a timestamp you bet on, the latitude, and the longitude. I'm kind of just use 64 here and 64, so I don't need to do time conversions. And for we be sure that like someone actually bet on that, we have to do the exact same operation here. Because we want to take the hash of it. And also we basically need to check this player actually bet on the values we want. So it's a timestamp. So, I'm sorry, actually, this will have to be not the one that they bet, but the one that we draw the results from. So that's kind of how this will work. And so just so I don't stay too long on these. Let's go just real quick of what the result will look like, because that's where the Tellor piece comes in, and that's how we get interesting results like from the Oracle. So as I mentioned, we will be betting on slots of 10 minutes. So if you think about like a timeline here, so for example, you have the beginning timeline, you have like a certain time, then a certain slot, then another slot, then another slot. And so, for example, the people who are betting on this slot are only able to bet from this point on. So they can only bet in future slots. And why is that? Because we have a real value from Tellor somewhere inside these slots. So for example, this is slot 0, this is slot 1. If you the miners will fetch the value from the ISS API, and they will provide the data on chain. It will be somewhere inside the slot. And if you can bet inside the same slot as this miners are putting Tellor values on chain, you kind of can game the system, because you can watch for the Tellor contract, in our case, the Tellor playground contract, and just bet in the results you saw the miners submitting on chain. So we kind of don't want that to happen. So for that, we just made a requirement for bets to be placed only on future slots. So we kind of know that somewhere around the second slot here, a Tellor value will come on chain, but we also need to wait for a little bit to be very sure that this value is legit. So like I said before, values can be contested, they can be disputed, they go through a vote, and if the value is not valid, they will not be available. So we cannot like just draw a value here and maybe a second later we can draw the result, because the value will be too fresh. Will be no way to guarantee that is a legitimate value. So we actually kind of have to wait another slot, and only in this like fourth slot you'll be able to draw the results for the people who bet on the 0 slot. It's a bit of time, but if you think about 10 minutes, it's not that much. So the first, the thing I'll actually do here is make a small function that just returns the current slot. I could start actually going from 0 to like when the contract deploys the 0 slot, but I'll just be a little bit lazy and I'll just do it. And I'll just return the block timestamp divided by a variable called like slot duration. So we can always like set it here. Will be line. And we'll put as 10 minutes, which is 600 seconds. I think it's that's also wrong. It's supposed to be here. Also follow here. I'm sorry, just like talking and coding at the same time, I might make a mistake. So that's the current slot. So for example, when the contract is deployed, will be, I don't know, in slot 50,000 or something. And to draw the result, we'll get like our current slot. Will be just this one. And since I kind of want to make this contract very simple, I also let people provide the slot they want to draw the result from. So the issue is like if we want to keep these contracts very automated, ideally it would just draw slots as it becomes available, but it kind of keeps, you get like, we have to make an assumption that this contract this contract will be called at least once every slot. And if we get with like a gap between calls, then we'll have some kinds of problem. So I just kind of want to go the fastest and simplest route and provide a slot for people to be able to draw the result from. And I'm kind of going from the principle that if you're winning, you kind of, it's in your best interest to actually draw the result for that slot, so people won't, so you can be able to draw your, like, to require your replies. So here, for these time guarantees, I just want you to make sure that this is what we are in, this is what we are actually drawing the results from, is at least 2 slots ago. And that will already make sure like that's because you cannot never like draw a result from the future or something like that. And that's the basic check we want to do. And also we want to require that the yeah, later on we have to require that these results wasn't bad yet, but I'll do that right now. So we got results, which is I do not have yet. So this is just going to be a mapping to hold the results. Kind of misname it. So we gotta make sure it's not already drawn a result. And then we will actually read the value from Tellor. So all the setup just for that. So inside this project, like using Tellor, there's a contract with a lot of functionalities, and you can kind of go through all of these functionalities, the documentation. But one piece I want to actually use is this function, get data before. And the main rationality is that I want to get the latest value of the latest lot, like this lot we are actually resulting from. So from the Tellor function actually returns three values. One is called retrieved, that if the value actually has been found. The other one is the white-wint with all the values you need, which is the actual value submitted by the Oracle and the miners. And the last one is a timestamp that says when this lot when this value was submitted on chain. And I'll just do a Tellor timestamp because it's not the same as the timestamp we are betting on. It's two different times and it's kind of confusing. I'm sorry. Yes, and get data before. And we're gonna pass the Tellor ID, which I defined up there, and it's 75 for our case. And here we need to pass the timestamp we want to verify this on. And so I do not have this now, but it's very simple to calculate. I'll create an int called time before. And that basically will be this lot we're trying to result times sorry, +1. Now it's time times this lot duration. Where did that came from? Oh, kind of deleted something. So this lot is actually like a number, and this lot duration, if you multiply this lot by the lot duration, you get the current timestamp. So for example, if you are like trying to draw a result from slot 1, we actually want the timestamp of like where it starts the second slot. That's where the second slot starts, and then we want the latest value before the second slot starting. So that's basically our time before. And this function should return for us the latest value provided by Tellor on chain that we can actually check to see what we got. So just like a requirement, it's a good practice just to make sure the value we get is retrieved. Otherwise, we'll be verifying for false results. And then I kind of need to take the value, which is a white-wint 2/6, to provide our latitude and longitude. So 164 longitude will be a y64 of the value that we just got from Tellor. And in this case, we won't have to do much thing because like the casting function will just take the last 54 slots. And so what we are doing with the Tellor value, it's basically the first 128 bits, it's for timestamps. It's for the timestamp. The next 64 is for the latitude. And the last 64, it's the longitude. So just by doing this kind of operation, casting, it already just takes the last 54 bits in this longitude to take it from us. But if you want to do that with the latitude, for example, you kind of need to do the same thing, but you have to shift left by 64 bits, which is kind of a scary operand if you're, especially if you're new to programming, but it's not, it will be fine. And the last one, it's a timestamp that we'll also have to move. And this was basically the way that we that I figured out of like taking a value that was not a numerical value per se. It is because it's a, I can put it in yint and feed it and use it in the Tellor system. Because if I couldn't use, for example, there are not all kinds of uses that you can fit inside a one int, a single int 268. But for a lot of those values, you can actually find a way to make use of. So for example, you can always have like some kind of I don't know, just like that. Like when I kind of defined the format where the batch we need will fit in the results that Tellor provides us, and that works. If the miners are aware of it and our contract is aware of it, it will probably work. So after that, we just kind of needed to, it's called slot results, right? And we'll probably have to hash this result here so we can there are a few other stuffs you have to consider. It's like, I think the main functionality is kind of already present, and you can kind of work with this. Oh, not here. This one is actually incomplete. So I'm just gonna finish the claiming process very quickly. And that will be the same here. And this is also a no, I don't think that I need here. And I'm pretty sure like this contract is almost done. Of course, I've done it in a few minutes, so there are a lot of holes in it and things you should consider. And I'll just do a naive transfer here because we got a winner, basically. The contract has like a jackpot, and whoever wins takes the whole jackpot, and then it is resetted with the ticket values. So basically, that's the whole project. I've kind of want people like I'll be publishing it on GitHub. I think it's already live, and if you want to take this idea and explore some more, go ahead. You can try different stuff with it. You can try improving it. I think it's very primitive right now, but it's a fun idea. And we'll be glad to hear like people hacking with this stuff. And also in our documentation, we have a page full of other hack ideas. I'm just trying to find it here. Which, if you're not sure what to build, there are a lot of those you can go through. Like, um, and you can also always like, I'll be on Discord, and there are also other Tellor people there, and you can tell us your idea and see if you think it's appropriate, or we can help you guide how to implement this in Playground so you can easily test without needing to actually get the value on chain. Um, so yeah, that's basically my idea. I hope you guys enjoyed. This will be very public. If you guys have any questions, I'll be happy to answer them.
Cool. I've got a question. Thank you very much for that, JJ. I've got a few questions. We've had an issue with Zoom, so people have had to message me directly. So first question is a general one. Can I use Tellor with any of Avalanche, Polkadot, or Binance Smart Chain? And Binance Smart Chain is EVM compatible.
Yeah, so as right now, we do not have the Tellor system deployed on any of those chains. So you cannot right now, but we'd love if you guys want to hack some bridges and be able to actually provide Tellor values on those chains.
Okay, next question. Why is Tellor better than the likes of Chainlink, Oracleize, Band, etc.?
I think the main difference, it's actually, we are actually decentralized. So I'm not that one, don't want to like to speaking bad things about other people, but our project makes sure of economic incentives and to be fully decentralized. So for example, if the Tellor team all dies tomorrow, the Oracle is still able to keep running. And we mostly rely on the incentives to, it's like, it's an open network. So everyone can join as a miner if you have the appropriate stake or the appropriate hardware, and we do not, it's censorship existence. So it's more or less like, if you really need, or if you really care about decentralization, that's kind of where you want to go with Tellor. Otherwise, the product will be only as decentralized as like the least decentralized point. And if you think about like how some other oracles operate, they like have a certain times of only a handful of data providers. It's kind of not that decentralized. So that's our main goal, like, to make a fully trustless oracle.
Cool. How does it work if the API requires an API key, or in fact, if the API takes parameters?
So actually, like the API, so for example, for this project, I actually built a simple API caller. In this case, it's an open API, but for the Tellor Playground, if you want to hack it, you just build a script and you just pass the parameters, but our miners are also able to support paid APIs. So for example, I know there are a few data that actually require um, paid APIs, and the miners just create a key and they get these values before submitting on chain in the real world scenario. In the playground scenario, you kind of build a system yourself and provide the value just like as you were reading from directly the API.
Are there any fees involved in using Tellor?
Right. So in general, like we provide a price every somewhat around 5 minutes for top 5 request IDs. So like I mentioned before, we have 50 of them, and the top 5, you actually have to tip if you want a value from it. So for example, if I want a value of like BTC USD price, I actually have to tip and request for it to be included in the next block. And if you are within the 5 bigger tips of the next Tellor block, you actually get this value. And that's it. Yeah, it's basically just have to auto-beat other people requesting data.
Okay. Someone asks, what is the geographic location of the miners?
I think they are spread all over. I'm not completely sure. I think we might have some dashboard on it, but I don't actually know, because I'm pretty sure there are some people here in the US, and I'm also sure there are some mining pools in China.
Yeah, I think the question was kind of motivated by kind of on the decentralization point, that a lot of projects are so they're decentralized, and then or they don't know where the nodes are actually running. So that's always I think a good one to ask. What if miners can't get or refuse to get an API key?
So that's a good question. Like, for example, the 5 top requests are provided by the smart contract of Tellor on chain. So if a miner wants to submit a valid challenge and wants to get his reward, he must provide one of those values that the smart contract is requesting. If he refuses to provide an API key and be able to capture this value, he won't be able to submit on chain, and therefore he won't be able to get his reward. So they basically have the incentive to actually get the value our people are requesting, even if you require them to have a paid API key.
Okay, cool. Any other questions, guys? So one from me. What would be what would be the best kind of applications you'd like to see on Tellor in the hackathon?
There are, like I mentioned, there are 2 big categories I really enjoy. I like DeFi products as anybody else in this space right now. So anyone that actually uses Tellor as an oracle, I think it's exciting. There are a lot of opportunities there, a lot of interesting products that to be made. And I'm also quite curious of what people can come up with, like other ideas. So I enjoyed like thinking about this space lottery, thinking about the position of the International Space Station, and there could be any other like a multitude of other data points, like bets in sports and bets in other kind of stuff, and and I'm I think like that's the main thing. I think DeFi will play a huge role. So people, if you are only thinking about building DeFi products, I think you can use Tellor like out of the gate. You probably don't even need the Tellor playground. But that's it. And I'm also interested what people can come up with different ideas.
Cool. Someone asks, can I build a can I continue building / build a better version of the space station predictor that you just showed?
Yes, please. I'll try to post on our Discord. I'll post a link to the GitHub as it is right now. You are free to take it, improve it if you want some discussions or what kind of improvement I would do or how to test it, and you're free to do it.
Next question. What did you build in the last hackathon?
Actually, I built a project called Atomic.Ninja. It's a it's basically I can actually show you here. It's a interface for you to build atomic transactions inside using very DeFi protocols. I don't want to show my own product much very here, but that's basically the idea. You can create a transaction that does a lot of stuff. Like if you can take a flash swap, and then you can take like a flash loan inside of it, and then you can, I don't know, swap something in Balancer, and that is using like a Google Blocks thing that was actually developed for people to teach kids how to code. So it's very intuitive, the interface right here. And yeah, it's kind of live. It's not fully audited, so please use with caution. And that was what I built.
What advice do you have on UI and UX in crypto?
I think like Jacob gave a good answer, like especially like if you're thinking about hackathon and if you're really strong in UI and UX, I think you should focus a lot on that and impress us with like the lean UIs, and don't need to worry that much about like the code base. I think very few projects will be like an end product with polish it and everything together. So as like an advice, I think you should focus more on your strong point. So if you're very good with contracts, I would like to see like a very well developed smart contracts, and I'm okay with a poor UI. Otherwise, if you're like a more front end guy with a UI view, I would also be very happy to see like simpler projects, but with a killer UI or a killer UX that does a lot of interesting stuff. So I just guess you have to play your strengths.
Okay, very nice. Any other questions, guys? Obviously, all the video, all the slides will go up afterwards. Yeah. Any other questions from anyone? That's my Discord. Awesome. Well, JG, thank you very much.
Thank
Anything
you.
else you want to say before we kind of close for today?
Yeah, just mention that we are in the Discord channel called Tellor, and you can drop by, ask anything. We'll be glad to help you.
Awesome. Brilliant. Well, I will upload the YouTube, or I won't. Someone else will. We will upload the YouTube and Mediums later today with the slides. But JG, thank you very much, and Jacob, thank you for JG for presenting. Guys, if you have any questions, please find me on Discord. But otherwise, have a good evening, morning, night, wherever you are. Thank you very much.